So last time we were doing integrals in polar coordinates. Your homework is due exam, basically. I can easily make it for Wednesday, Tuesday, I don't mind. But the whole point, you should finish it before the exam. Because it is on the exam, you know.
Can you make it due Saturday?
No. Then we learned that it has a different formula. And the most important part is this R, d theta, right? R. R. Can you guys say the R sound? No. Carlos can. R. Right? So, we did a problem. In general, when you see x squared plus y squared, you shift it to r squared right away. And that's the hint. Done gossiping. Thank you. So, and then on the exam, we're going to tell you actually, use polar coordinates. If you stuck with polar coordinates, just write down the formula, r squared equals y squared plus x squared, and it should hint you how to start, and you will not freak out anymore. But like Jacob mentioned during the office hours, the hard part is to figure out the limits of integration. So what we're doing right now is, for the first time, we're going to do the volume between regions, not above or below. And we're doing it to find the size, the volume of this snow cone or ice cream cone. We want to find the volume between two regions, square root and a square root. When I'm writing the square roots, the first one is upper half cone, and the second one is a sphere. They cut off a beautiful region which looks exactly like the ice cream cone. So there is a sphere in blue, upper half of the sphere. And inside we insert this. You guys, thank you. Now, here's a beautiful picture of what we did. So the thing is, whatever goes inside is usually pretty simple. Either we give it to you right away and you just plug it in, or you do bigger minus smaller. From the picture, what is surface in this 3D space is on the top. This sphere is on the top. So this sphere went first, minus what was at the bottom. The part of the cone was at the bottom. So it's very typical, bigger minus smaller. If you choose type 1, it's top minus the bottom. So the cone part went with a negative. That is not a trouble. The trouble is to find the limits of integration. So limits of integration, we're not going to do it in dx and dy. We want to switch everything into polars right away. Too many square roots with x squared and y squared. And that's the nice hint that it's time to switch. So people usually don't do. We will be asking you on the final exam, switch from Cartesian to polar, switch from cylindrical to Cartesian, and so on. But in general, you just choose to work based on the example, on the equations you see. You see too many square roots and too many squares. You see the rotation. You see that this 3D object is made from a circular rotation. That is polar. And like I mentioned last time, if you don't remember, polar equations help us to identify some integrals and solve them when they used to be unsolvable in Cartesian. So we're using extra tools to solve there. Now, the limits here will be coming, as always, from some kind of intersection. You should see this ice cream from the top, like you bought it, you hold it in your hand, and you're looking from here. So this is your eye, and you're looking down. You will see now a circle. See this D at the bottom? This is your circle. So you see a circle when you look it down. You need to see how the circle is shaped, and it's very typical circle. Not only the theta will be completing the whole circle from 0 to 2 pi for theta, but also the radius is not just this length, but it has to fill in all of this. To fill in, all this type of radii should be included. So radius is changing from 0 to the longest one. That's a very typical idea, to be honest. So radius is keep increasing to fill in. Radius is keep increasing left, right, back, front. And then pi is keep rotating the radius. And that's how you get the whole filled in ice cream. Kind of makes sense. So we just need to find this intersection, how big the radius of this side of this intersection part is. That's why we set up two equations equal to each other. When the cone meets, oh, that's a sphere. When the upper sphere meets the cone, they surprisingly are not intersect in the circle because they both have circular shape. I squared each and I got a circle with the radius 2. Circle is what's gonna tell me what is the largest R is going to be, but actually it's a disk. And a disk is different from a circle because it's all filled in. So now we know theta indeed starts from 0 and spins until 2 pi. Radius indeed starts from 0, the smallest radius, and then we have to include all types of radii. Finishes at 2 because that's the biggest radius it can get, as big as that. Good morning, and now we are building the integral. Thus, the integral will be, so remember, this is how you should do it on the test. Honestly, this is the best way. Integral r d theta. You can get angry on the test as well. Maybe it will help you. But that's the thing, don't forget the r. Because I already can see in multiple choice, we'll have 2 obvious wrong answers. They will not have r. So boom, you cross them off. There should be r in the formula. Unless it's simplified, of course. The function inside was created like so. Sphere minus cone. We need to convert each into the polar equations. Do you all see that this is 8 minus r squared in a square root? And this is square root r squared? No. So, to convert, remember that r squared is x squared plus y squared, right? Then 8 minus x squared plus y squared, I'm factoring out the negative sign, is 8 minus r squared inside of the square root. Make sense? So let me write it down over here. The cone became a square root of 8 minus r squared. That is my cone. And then the sphere minus the square root of r squared, which is just r. But don't forget, what did I forget? R d theta. R d theta. So, now limits of integrations are fixed based on the order. Be careful with that. If your theta is at the end one should be about theta. Theta completes the whole circle of the ice cream. So it's from 0 to 2 pi. R is inside. So R will be from 0 to 2 because we just learned that this circle, which is intersection, is from 0 to 2. Because it's x squared plus y squared equals 4. And this is basically what will cost you the most points on a test. To be honest, if you fail to do U substitution and integrate it, you probably will lose like 4 points or 3 points. But building the integral is important. So I need to see you building the integral correctly. That will give you lots of points to build the integral. But you're supposed to know integration by parts and U substitution from previous calculus classes. So I put lots of videos for you to review that, but I can do it one more time right now. Let's keep the outside integral for now and multiply out, let's keep both, and multiply out everything inside. From 0 to 2, I will have a square root 8 minus r squared multiplied by r minus square root of r squared is just r. R times r is r squared multiplied by r, right? dr d theta. See, r disappeared because I distributed it. That's a cute dress. Thank you. Now we have 2 integrals. One will require U substitution and the other one will not. Sometimes people like to break it into half, into 2 pieces if you want. So you don't have to be honest. Depends how good or bad you are with U substitution. How to integrate this part? You see that one piece here, r, is almost as a derivative of another piece, 8 minus r squared. See, it's exactly what I showed here during the office hours. Let's call this u. This is u substitution was created to undo chain rule, because chain rule have a piece times derivative of that piece, more or less, times or minus constant. If u is 8 minus r squared, also hint, you don't like square roots? Make everything inside with the square root u, it makes it easier. Then du will be minus 2r dr. You have, well, fine, let's just solve for dr. That's not the way I usually do it, but it's okay. You solve for dr, that's how your teachers probably were teaching you, except me. Du over minus 2r. And you're also supposed to change limits of integration. Not always, but it's hard to explain now. I explained it in my Calculus 2 class, when you can and when you cannot. 0 becomes 8, because u is 8 minus 0 squared. 2 becomes, 2 times 2 is 4, 8 minus 4 is 4. So, we're only doing it for this inside integral. Sometimes people just call it, let's call it integral I1. That's a very nice convenient notation to say we are only integrating this integral from 0 to 2r as square root 8 minus r squared dr. Only this part, because it requires u substitution. Using u substitution, it becomes, r is now from 8 to 4, and then, which is okay, why not? This square root gives me a square root of u, and then r, dr you just solved will be dr, you plugging this part. Dr is du over minus 2r, but there was r in front, and it's supposed to cancel out. So I usually do a shortcut of this, it's easier, but if you're really not comfortable with your substitution, this way always works. It cancels out r, and then negative 1/2 pops out outside. Negative 1/2 showed up, integral from 8 to 4, a square root of u du. U substitution creates from a harder integral an easier one, because it's working with a result of the chain rule. It's undoing chain rule. Negative 1/2, you could flip the limits of integration to be from 4 to 8 will be positive. U is raised to the 1/2, so it's going to be raised to the 3/2 over 3/2 bar from 8 to 4. Negative 1/2 is multiplied by reciprocal, so it's going to be times 2/3. U plug 4 to the 3/2, 3/2, and plug 8 to the 3/2. It is some kind of number because it's a square root after all. Who knows what it is? I'll simplify this. Negative 1/3. So it's more like algebra stuff here. The square root of 4 cubed. 2 times 2 times 2? 8. Minus, and this one is a square root of 4 times 2 cubed. So it's a square root of 2, well, cubed, blah, 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 2 times square root of 2 cubed. So it's 8, 2 to the 3/2, something like that. Anyway, we're going to have final number at the end. So this is the result of the one inside integral, which we still need to integrate later with respect to theta. So that's not n. And there's also this part is missing. So that's what we're going to call I2. Let's call this second part to be I2. So we finished the hard part, which required u substitution. I2 is not requiring the u substitution. It's just r cubed over 3. Again, I will try my best, and it's probably gonna work, not to put any hardcore calculations on the exam. But for your homework, you're supposed to suffer, so keep suffering. I'm very honest about that. Homework is called homework, suffering work, right? So integral from, what was it? From 0 to 2 minus r squared. Well, let's do from 0 to 2 r squared and dr. And then we're going to do subtraction. Is r cubed over 3. Let's hurry up. From 0 to 2. 2 times 3 times 2 is 8. 8/3. Second one was easy. Finally, we have integral from 0 to 2 pi. So d theta was waiting all this time. Of I1 minus I2 d theta. You don't have to do it this way, but it's convenient to name them somehow. That's why we did it. We looked at this separately like so and broke it into two integrals, both in like so. I1 and I2. Very nice. And we finished integration and got numbers, which is very nice. The answer should be a number because it's a volume. So I have integral from 0 to 2 pi. The first integral is that awkward number, minus 1/3, 8 minus 8 times 2, 3/2, minus the second number, 8/3, d theta. If there is no variable involved, there's only constant, and integral is from 0 to something, doesn't matter actually. The answer will be this number times the length of the interval from 0 to 2 pi is just 2 pi. So that is what we learned in calculus 1. Or you can just do theta and plug top minus the bottom. The answer will be the same. This is algebra. Algebra, yeah. It's your bro. Algebra. I don't know. That's people like this joke. Just a second. Let me write down 32 pi over 3 square root of 2 minus 1. The volume should have a positive number. If on a test you give me volume negative number, I will laugh at your face. I will like call your name in class and say your volume was negative, and you will say, well, I was too stressed. But like seriously, yes. Okay. Yes, definitely. Oh.
What's the approximate answer of that?
Who can tell me approximate answer?
Thank you. About 32.
Oh, let's see. About 32.
1 minus.
Because pi is 314, cancels out 32. Square root of 1, yeah, it's a little bit more than 32.
Yeah.
Square root of 2 is like 1 point something. Pi is almost 3.
13.88.
How much?
13.88.
Not even close to what we just said. 13.88? Really?
Yeah, I got 13.88.
Well, pi is about 3.14, and you did this
But the
cancels out,
calculator
so you
said-
have 32 times
Calculator can't
1.5. I had imagined it was a little bigger.
Yeah, it should be a little bigger.
Yeah.
Someone should check one more time.
I know. That would explain a lot of what I did wrong with my
Imagine trying to be very innocent and giving a calculator answer and everyone's coming after you.
Oh, that's interesting. So, one more thing before we move on.
How am I getting 30?
Let's do this one. I like exact answers, so that's good. So the average value. We keep mentioning this average value since class 1, calculus 1 class of the function. We actually keep mentioning average value and mean and mode from college algebra class. You do understand that average exam grade is you take all your exams, divide by 4 because we have 3 midterms and final, and it gives you the average value of the exam. It's always the same idea starting from 2D, which is interval. So in 3D, it becomes an area and so on. And that's why the idea is the same with volumes. When you take double integral, it gives you a volume. The function floating in the air is f, dx dy. Well, you had it in your homework. And then you divide by the area of d. So that's like how many exams did you take, right? So that makes sense. Your grades is accumulation. So it's in the numerator, but in 3D. And then divide by how many exams you took, that's the area. So its idea is the same. You just keep exploding into multiple dimensions, higher dimensions. So if we ask you to find the average value, example, find the average, okay, let me write down, average value of, and then we give you some kind of awkward function that usually is the hint that we're not supposed to work in Cartesians. And you will see why it's better. Arctangent, so it's tangent minus 1, of y over x over the ring D. The ring D. And D is between. So what is a ring? There is a disk and a smaller disk. The area between those called a ring. So it's literally a ring. We used to call it with the volume. Remember washer in calculus 2?
No.
In flat, it is a ring. Between two circles, x squared plus y squared equals a squared, and, let's put and, x squared plus y squared equals b squared. Where, which one is bigger? A is smaller than b. So this will be a, and this will be b. Like so. Again, the moment you see some circular behavior or circular ideas, you should switch to polar coordinates and everything becomes super simple. Because if you don't, you will have to work with arctangent, and that's just not what we want to do. We don't want to do with arctangent if we can always switch. But do you know how to switch from arctangent y over x into polar? Solution. With polar equations, just like I mentioned in calculus 2 class, we just give you like 4 formulas, and usually that's all you need. So if you have a panic attack during the exam, and you look at the polar equations, you're like, oh, I don't understand polar at all, I'm gonna fail right now. At least write down those 4 equations. It might click, at least something visually will match. I remember these formulas. The formulas for x is r cosine theta. The formula for y is r sine theta. The formula for x squared plus y squared is r squared. And there was one more.
What? Tangent theta equals
How to find the angle? Tangent theta is
x over y.
y over x.
Something like that.
Because sine over cosine, okay? Sine over cosine gives you tangent. X over y will be cotangent. And r cancels out. So we only have 4 formulas. That's all. And now you stare at your problem on the test, and it's supposed to click, right? Does it?
Can we just say is it theta?
There is a theta there. So theta, like the theta from here is exactly tangent minus 1, which is arctangent, of y over x. Here it is in the box. Moreover, this is r squared, and this is r squared. Duh. So it's very nice. So everything will be switched nicely into the polar. So this is polar versus rectangular. Rectangular or Cartesian, what? Rectangular. Yes. I got it. So we are going to say that the function f, which was tangent minus 1 y over x, is actually just theta. Magically, it just all converted into one variable theta. So convenient. It's much easier. Then we can start building the integral. Build the polar integral. Integral. What did I say? R dr d theta. See, good job. Someone got it. R dr d theta. Honestly, the good joke will help you to memorize the formula. There is I have a friend now from PhD of psychology, and she studies sense of humor and the connection between sense of humor and learning. And now they have new research saying that sense of humor and jokes help you to learn and memorize hard formulas. You see?
That's why everyone's passing.
Right?
That is true.
R theta.
It's
Dumb jokes, but like on the test, you remember them. Someone actually made notes on my exam saying, sine is good, cosine is racist.
Wow, that just...
It may be even in our class, but I would not tell you. Because of the formulas, sine at 0 is 0, sine is the 1/2 formula, sine, or a cosine only likes cosine, so 1/2 formula gives you 1/2, 1 plus cosine,
There's a lot more now.
right? And then, so I was saying cosine likes itself, so it's keep adding up, and that's like, it's really,
I can do the math.
whatever you like, just remember it, Theta goes inside,
Because cosine only likes itself.
right? Because cosine likes itself. So, what is my r and theta? Remember my hints for the test. If there's a full circle going on, then you definitely at least know one thing on this test. Theta is from 0 to 2 pi, okay? And it's the outside one, 0 to 2 pi. Usually you see the circle. The full circle was completed.
But if we only say half the interval, how many points will we get?
Half will be, oh, you will see. I don't know, actually, yet. I need to decide later. Yeah, I will. You will see on the exam, yeah. Now, the hard part is to figure out your R. If you have a disk like we had before, completely filled in, R will be from 0 to this, whatever this radius is. If we have, I don't know, if we have this shape, R is still from 0 to whatever this is. But in this case, we have a disk. The disk starts not from 0. It waits and starts at this smaller radius, and then ends at the bigger radius. What are these two radii? A and B. It's written over here. So radius R now is running like so. I will zoom in for you. Like this, R. It looks like a cute donut now.
It looks like an eye.
Oh. Okay, it is true. I see you. Yeah?
The world.
So I'm hungry. Yeah, that's true. So, radius is from A to B. Make sense?
Yeah.
And now let's finish integrating. We have two variables inside of the integral. Do you see that? Theta and R are both variables. So you can choose, since you have all numbers, which one you want to integrate first. Doesn't matter, both are easy in this case. Moreover, you can break into two products of two integrals. Product of integral with theta d theta and r dr. And it doesn't matter, let's just do one. Theta r with respect to r will be theta r squared over 2 from A to B d theta equals integral from 0 to 2 pi, it's keep waiting. Theta is a constant, that's why it's state. R squared becomes B squared over 2 minus A squared over 2. A d theta. B squared over 2 minus A squared over 2 is just a constant. I will kick it out. And actually it's just B squared minus A squared over 2. Looks like the average of the interval actually we learned before. Now, integral of theta will be theta squared over 2 plus 0 and 2 pi. 2 pi goes first. And 0 gives you 0, so it doesn't matter. And the answer follows. B squared minus A squared over 2 times 4 pi squared. We can cancel out with 2. And the answer will be pi squared times B squared minus A squared. The average value, the average volume of the disk is apparently pi squared, and then the difference of squares between two radii of each circle. That is, the question was find the average value of the function over the ring between two circles, the bigger one and the smaller one.
Should it be 2 pi?
2 pi, yes. Good catch. I did it on purpose for you to check. But it says, no, let's see. This 1/2 got lost. I think I lost 1/2 somewhere.
No, you just canceled it out before.
But I have one more over here. No, looks good to me. Interesting. Okay, let's do 2 and then I'll check at home.
No, that works. Cancel 2.
Oh,
Cancel.
this, yeah, over here. Yes.
Oh,
Yeah.
right.
Now they all cancel out. Thank you. I got it.